many Caribbean islands, Montserrat was formed millions of years ago by a volcano. This fiery origin never much bothered the residents. Then in 1995, after lying dormant for nearly 400 years, Montserrat's volcano burst into life. This type of volcano doesn't produce much red-hot lava, but something much deadlier. A mixture of ash, rock, and gas called pyroclastic flow, traveling over 100 miles an hour with temperatures over 1,000 degrees. Dozens of eruptions over the next 2 years devastated nearly all the major towns on this island paradise. Intense heat from the pyroclastic flows had literally melted steel frames of buildings. Most residents and vacationers abandoned the island. But about 3,000 people decided to hang on, like taxi driver Willie Morrison.
I don't want to leave Montserrat. I prefer to stay here. I prefer to die here. This is anything, everything, and anything that I have, I own it here in Montserrat. And I decide to just weather it out. Montserrat is going to bounce back, and when it bounces back, some of us will be very happy.
The northern third of Montserrat is far enough away from the volcano to be relatively safe. So all the stay-behinds have moved here to rebuild and get on with life. They talk about returning to the evacuated area, locally known as the exclusion zone, and they constantly listen to the radio for encouragement and hopeful news.
At this time, we bring to you this morning's volcano report from the Montserrat Volcano Observatory. Overnight, the volcano has been relatively quiet, with a few rockfall signals being the only seismic activity. It can be assumed that the dome is continuing to grow in the crater formed by the Boxing Day collapse.
Early on Boxing Day, Montserrat's volcano erupted with unusual fury. The event was closely followed 8 miles away at the Montserrat Volcano Observatory, where scientists from around the world try to predict new eruptions. They watch for ground tremors picked up by seismic stations buried all around the volcano. Usually, tremors mean there's an eruption coming, but not always.
This station is right on the very edge of the exclusion zone, and they're actually digging a landfill site. So that is a bulldozer, which is digging right near the station.
On Boxing Day, all the seismic stations were picking up tremors. These lasted for hours, and then...
What actually happened was a big pyroclastic flow at 3 o'clock in the morning, which is actually the biggest we've seen so far.
It's now a few days after that eruption, and scientists Simon Young and Barry Voigt are heading out to survey the damage for the first time. Near the top of the volcano, the ground is still smoldering, and you can see where the rock and ash flowed into the ocean down below. Our crew was only allowed to come on this mission if we stayed near the helicopter at all times, so we attached miniature cameras to Barry and Simon's helmets to follow the action.
So is that impacted, Barry?
Their first task is to collect rocks which were blown out of the volcano and went for miles. The rock barrage was devastating.
Anything which stood above the ground here got knocked over. Some of the things which are the trees and so forth that got bent over pretty low managed to survive. But the houses which were standing in this location beforehand are now out in the Caribbean Sea.
Because the volcano could erupt again without warning, the helicopter is left running, ready for a quick getaway. Barry and Simon work quickly. Their trench reveals 3 layers of ash, indicating the eruption occurred in 3 waves. The first wave was traveling almost 200 miles an hour, they calculated.
There was a seismometer operating here, and we know what time the explosion started at the top. And we know what time the seismometer got killed at this location. So we haven't been back to visit it, but we now want to see just see what kind of damage has occurred, whether just the antenna got knocked over or whatever. But in any case, this is important information from the point of view of determining velocity of the flowage.
The rock barrage that wiped out the houses completely obliterated the seismometer. This is a piece of someone's fence. But the speed of the flow was a blessing in some other ways.
You see right next to this completely devastated charred branch here, small tree, there's some green shoots already coming through this deposit. What that indicates is this thing is firstly quite thin, but also it suggests that all the heat was very quick. It didn't really penetrate very far down into the earth, so it didn't kill off all the little seedlings resting in the soil, so that fairly soon after they get water again, they can start to grow again.
After an hour, Barry and Simon have collected dozens of rock and ash samples to be sent off the island for analysis. As part of the observatory's routine, Rick Hurd and Lucy Ritchie keep a constant watch on the volcano's rate of growth. It's one of the best predictors of when it will erupt again. They head out for a point with a good view of the volcano's top, and that means crossing into territory that's strictly off limits to the public.
Just go to the old observatory site. Okay, no problem.
This area hasn't been hit yet by the volcano, but it's dangerously close. As always, Rick backs into the driveway, just in case. Before the area was evacuated, this was the Montserrat Volcano Observatory. And before the first eruption, it was a luxurious vacation home. Once a week, Rick and Lucy come here to try to measure the volcano's dome. That's the part above the pre-eruption summit, where the lava builds up and eventually explodes. Today is the first time in 2 weeks that the dome is visible through the smoke and steam.
Getting conditions like this is essential, because if you can't see it, we're a bit stuck.
Rick and Lucy measure the precise angles to about a dozen recognizable points on the dome.
Okay, right, let's get number one. Big spine.
Big spine is that tombstone-like piece of rock sticking up on the right side of the dome.
3, 4, 4, 4, 3.
3, 4, 4, 43.
By combining measurements from this and the second location, they work out the latest contours of the dome. Over the last 2 months, the dome has grown rapidly, adding a house-sized volume of lava every 10 seconds. For predicting eruptions, it's also crucial to know whether the sides of the volcano are bulging or shifting. After a tricky landing on the roof of an evacuated house, Rick and an assistant don their helmets with our helmet cams and head for one of 6 locations around the volcano. Their goal is to figure out the exact distance between the locations to see if they've moved. They're miles apart, but just the change of an inch would be alarming. At each location, they set up a GPS receiver, which uses satellite signals to pinpoint the position. Risky operations like this allow scientists to keep track of the volcano. But whether the people of Montserrat will ever get most of their island back remains very uncertain.
You know, it may settle down for a few years, and then, 20 or 30 or 50 years later, it may erupt again. I would be hopeful that they could develop it for farmland and so on, but I don't think there's much prospect of living up here for a while, a long time to come.